A, well, what quantity do we have to figure out in order to figure out how much time it takes? What? What we need here is we have to figure out V. And then it's, you can think of it as just like a 1D kinematics problem or something. So if we have to figure out the wave speed, we have 3 different equations for wave speed. Which type is this? So we have longitudinal waves in gas and what? Yep, this is a transverse wave along a cable. So the wave speed is equal to the force of tension. I'll just write out the formula first. Divided by the mass per length, take the square root. So the tension was equal to 200 newtons. The mass, the total mass was 10 kilograms. And that was divided over 20 meters. Or another way to think about it is it's half a kilogram per meter. Take the square root of that, and you get a value of 20 meters per second, which makes the next step in this. Any questions on that? Okay, so then the next step is really easy because it happens to be that the length of this is 20 meters. The speed is 20 meters per second, so it takes 1 second to get there. But you could also think of it as, you could set it up as like the way we talked about 1D kinematics. You know, we know, well, we want to find, no, we know the initial position is 0. We know the final position is 20. We know the initial velocity is 20 meters per second, and it's constant. We're never talking about accelerations. We're trying to figure out time final, you know. And so you could set it up as 20 is equal to 0 plus 20 TF plus 0, and TF is equal to 1 second.
So would you say that's what we have to do for a majority of the calculus? Do like 1D kinematics?
Any problem that asks how long it takes to get somewhere or how far it travels in a certain amount of time, you can use 1D kinematics. I think some people would prefer to just do it in their head, and on all these problems you can get by that way probably too. So it's your preference, but you always could use this. So, and then the second one, the wavelength. So what do we need? What quantities do we need to calculate the wavelength? Right, we're going to use this formula. The wave speed we just figured out. But what about the frequency? How are we going to get that? Yeah, right. So 1 over the period, but we don't have the period either. So we have to use that omega formula. What we're given is omega is 10. Okay. Any questions about spotting that one? Okay, so omega is 10. The period then is 2 pi over 10. The frequency is 1 over the period, which you could get by just flipping these. So it's 10 over 2 pi, and you get an answer of 1.59. hertz. And now plug 20 meters per second and 1.59 into this formula, and you get a wavelength of 20 over 1.59, which is 12.58 meters. And so what that tells us is if you took a snapshot of it at one instant, from peak to peak in your snapshot would be 12.58 meters. And so the shape of the wave would look something like this, you know, about this length, where this whole thing was, I mean, given that this whole thing from the hand to the wall is 20 meters, a single wave would take up more than half of that length. Any questions about that?
Yeah, I'm sorry.
Yeah, sure.
You got laws between the period and frequency.
Oh, yeah. Okay, well, frequency is 1 over period. And 1 over also means if you have a fraction, just switch, just flip them. So I just flipped. Period was 2 pi over 10. So 1 over period is 10 over 2 pi. Any other questions? Okay, that's it for today. Oh, yeah, I said no lab.